And our final speaker before the break is Amir Bandeali, who is the founder and CTO of 0x Protocol. 0x is a globally distributed group with backgrounds in engineering, research, business, and design. They're passionate about decentralized technology and its potential to act as an equalizing force in the world. Amir.
Hey everyone, how's it going? So today I'm going to talk about some of the features we're implementing in version 2 of 0x Protocol, which we're planning on releasing in the upcoming months. Specifically, we're going to be looking at 3 areas of the protocol that we're generalizing in order to make it much more flexible than version 1 of the protocol. So quick recap of version 1 for those who aren't familiar. 0x is a protocol for decentralized exchange. And initially, it only supported the exchange of ERC20 tokens. Makers create off-chain orders that specify the parameters at which they wish to trade. And then a maker includes an ECDSA signature that proves the authenticity of the order and makes it valid. Then relayers broadcast these signed orders to the public, allowing traders to easily find counterparties for their trades. And when a taker sees an order that they want to fill, they create an Ethereum transaction that calls one of the 0x exchange contract methods. And then once that transaction is mined, the actual swap happens and the trade is settled. So in version 2, we are abstracting away 3 of these areas. The first one is the type of assets that can be traded. The second is the types of signatures that can be used to create valid orders. And the third is how transactions are actually submitted. So in version 2 of the protocol, we are modifying our architecture in a way that will allow us to add any arbitrary token standards to the protocol as we wish. And we can do this without upgrading the core exchange contract. Initially, we will support ERC20 tokens and ERC721 tokens. In my opinion, this will allow the token ecosystem to evolve at a much more rapid pace because you could guarantee interoperability between the different token standards. So now you can create a brand new token standard, and it'll be much more likely that that token is still liquid. So here's a quick snapshot of what the new architecture actually looks like. So you can see we have our exchange smart contract, and then we have these different asset proxy contracts for different token standards. So an order contains different fields for maker asset data and taker asset data. These fields contain data that are that's specific to token standards that can be decoded by these asset proxy contracts. So the asset proxies decode these byte arrays, and then they perform the actual transfer. And all of the encoding is done off of the blockchain, so we can always add new asset proxy contracts that are able to decode the data in different ways. And this allows us to easily add any new token standards into the pipeline. Just as an example, ERC21 data is encoded as the address of the token, the ID of the token, and then the proxy contract ID. Secondly, we are generalizing what types of signatures can be included to create a valid order, different signers and clients. An example of this is Trezors. We're also using EIP 712 hashes in version 2 of the protocol. So EIP 712 is a standard for hashing typed data. So when using this, if you sign an order, you will be able to see the exact parameters of that order in the UI, rather than just seeing that you're signing some arbitrary 32-byte hash. So this will greatly improve UX around signing orders. We're also adding support for signing on behalf of wallet contracts that actually hold your assets. So an example of a use case here is you can actually create orders from a multi-sig wallet using multiple signatures from the owners of that wallet. Users will also be able to delegate signature verification to external validator smart contracts that can contain any arbitrary logic. So you could really use any signature scheme that you want with 0x orders by doing this. Some other cool things you could do here are that you could create signatures that are valid based off of some existing blockchain state. So for example, I can create an order that can only be conditionally filled if another set of orders has already been filled. Or I could create a single signature that would make multiple orders valid. There's a huge design space to work with by using this signature type. And finally, we are abstracting how transactions are actually submitted to the blockchain. So now, if I want to fill an order, I can sign the call data for that transaction, and I can pass it off to a third party to actually submit that transaction to the Ethereum network. So this, first of all, this allows a third party to pay gas on my behalf, which can improve UX for a number of dApps. But more importantly, what this allows is the ability to add any custom logic before or after an order is filled. And that custom logic can actually be tied to specific orders, and that logic would be guaranteed to be executed. So some cool examples of things you could do with this. You can create a whitelist, and you can create orders that are then only able to be filled if both parties in the trade are on that whitelist. This is useful for implementing KYC or AML, for example. You would also be able to create orders that cannot be partially filled or canceled. You could create orders that can only be filled with a certain gas price. These are just a couple examples of things you could do, but really you can add any arbitrary logic before or after filling an order. This also maintains wallet-to-wallet trading when using these filter smart contracts. So this is important because a lot of new token standards that come out are adding extra validation to transfers of the tokens. And as soon as you deposit those tokens into a new smart contract, you lose that extra validation logic. But by keeping wallet-to-wallet trading, you can always ensure that that logic is executed every single time a trade happens. So this is what the pipeline would look like for the execution of an order that uses a whitelist. So you can see that the entry point is a filter smart contract. This contract would contain a whitelist. If someone tried to fill an order, the contract would check the whitelist, and then it would call into our exchange smart contract, which would then use the regular pipeline of contracts for the trade to actually occur. So in summary, in version 2, we will be generalizing the types of assets that can be traded on the protocol, the types of signatures that are used to create valid orders, and how transactions are actually submitted to the network. This will greatly increase flexibility and extensibility of the protocol. We'll be able to add a lot of cool features to the protocol without having to upgrade our entire system of contracts. And this will allow us to iterate at a much faster pace. This will also future-proof our contracts in the future when new standards are constantly being added. And finally, this will create many more strategies that relayers can employ, which will allow them to compete on many new verticals. And I believe this competition will lead to an increase in user experience. And finally, we are hiring. We're hiring for all sorts of roles, including engineers, researchers, and various operational roles. So please check out our website at zeroxproject.com/jobs if you are interested. Thank you for having me.